Hi, welcome to this AQA GCSE Maths paper prediction for the Paper 2 Calculator Higher Tier paper. Enjoy! Hi, I'm Chris Gilpin and I hope that Paper 1 went well. From what people are messaging me, it seems that it went okay. But a lot of you are looking to revise for Paper 2 and 3. Now remember, Paper 2 and 3 are not really that different to each other. It's basically a 3-hour paper split into two. So when you revise for Paper 2 and 3, as long as you've got a calculator in your hand, you're good to go. Don't forget that all of the stuff that we're going to see in this video you can do on the site, completely free. If you go to onmaths.com, I'm sure there's a link coming up there now. And on the site also there's topic busters. In fact, we're finding that on the site many people are now going to the topic areas and revising specific topics, which is fantastic. Like I always say, don't rely on this prediction as an absolute this is what will come up. It never works that way. What this prediction does is it first of all gives you some practice of GCSE style questions. It also, I've removed all the stuff that's come up in Paper 1 so that you can practice the topics that are more likely to come up. Especially ratio and proportion. Don't think because ratios or proportion questions come up that it can't come up again. All the exam boards have shown that they have repeated some topics. Probability is a good example as well, because probability has loads and loads of different types of question, and although probability may have come up in Paper 1, it doesn't mean it can't come up in Paper 2 and 3. So the safest bet is first of all focus on the calculator questions, because it's unlikely there's going to be ones that require not a calculator but you've got a calculator in your hand. They're not going to come around and take the calculator off you. These are now both calculator questions. So during this half term and during up until the exams, have your calculator in your hand. That's your best friend now. You don't need to worry about the non-calculator questions. Other than that, revise everything. If you go to our site, there's loads and loads more stuff. We're adding more stuff all the time. Such as demon questions, the revisionator, etc, etc. We're making a few changes to the site, so please just have a look on the front page and just see what's going on, and I hope you enjoy this video. Thank you very much. When you're asked to describe the relationship between two things on a scatter graph, the sentence you need to write is, as this one increases, this one either increases or decreases. So as time of day increases, test marks, and because they're going up, it's a positive correlation, test marks increase. So there's a difference between describing the type of correlation or writing the type of correlation and describing the relationship. When you're describing the relationship, it's just as the one at the bottom increases, the one up the side either increases or decreases. So it says, using the scatter graph, the examination centre then conclude that time of day leads to positive effect on test scores. Are they correct to make this conclusion? Basically, this is a question about the fact that just because two things correlate does not mean that one causes the other. So a sentence like there may be other factors such as, I don't know, what else? Tiredness, fatigue, tiredness. So try and make sure you give an example as well to support your argument. Now, a lot of people look at the word estimate and think, oh, let's just take a guess at it. The reason we're estimating is because of the first step that we have to do to answer this question. It doesn't mean that just have a quick punt and guess at it. With this question you won't be able to guess it correctly, or it'd be very, very unlikely. So We approach this the same as if it wasn't a group. However, we do have a group, so we've got to do a step first. This means that we've got a value somewhere between 0 and 4, including 4 but not including 0. Now the problem is that the first step in this method is to multiply these two numbers together, but you can't times somewhere between 0 and 4 by 14. So what we need to do first is find the midpoint. The reason we pick the midpoint is it's a good number to use to represent that group. If we assumed all those numbers were 0, then it would probably be ridiculously small. If we assumed they were all 4, again it would be too high. So we assume that all those are 2 because it's right in the middle of the group, and chances are that most of them are closer to 2 than 0 or 4. So we find the midpoint of each of the groups, and the way of doing this is just adding the lowest and highest value together and dividing it by 2. Or just having a look. 4 to 8 will be 6, 8 to 12 halfway would be 10, 12 to 16 halfway would be 14, and 16 to 20 halfway would be 18. Then what we do is we get the frequencies and times them by the midpoints. So it's the same as if it wasn't a group now. So we do 14 times 2, which is 28, 6 times 6 is 36, 3 times 10 is 30, and then you can use a calculator for this, so 9 times 14, have an idea of what it's going to be. Hopefully it's 126, which it is, good, and 2 times 18, which is 36. And this is I call this the fx, although in this case we are calling the first one s, so it's the fs column. And then we need to find the sum of the fs column. So we're going to add up 28, 36, 30, 126 and 36 on the calculator, which is 256. And then we're going to sum up the frequencies, which is this column here. So 14 plus 6 plus 3 plus 9 plus 2, which is 34. And then what we're going to do is we're going to get the 256, which is all our values added together, and divide it by 34. So 256 divided by 34. And I get the answer of 7.5294 blah blah blah. And to 2 decimal places, that's going to be 7.53. Now, the reason it's an estimate, as I've said before, is that we don't know that all the values in the first group are 2. We are estimating them to all be 2, even though we know that some of them will be 1, some of them will be 3. But chances are it will balance out that it's roughly going to be about 2 in that group, and 6 in the next group, and 10 in the group after. That's where the word estimate comes. The method for doing this is how I've shown it here. I don't believe there's any other methods you can use for this. Okay, so we're given the density and we're asked for the mass, and we can work out the volume. So the first thing I'm going to do is just draw my triangle, and it's density, mass at the top, volume at the bottom. So to work out mass, I'm going to do density times the volume. Okay, so we go, first of all, have to work out the volume. And of a cuboid, it's just timesing all the dimensions together, so 33 times 22 times 7. So 33 times 22 times 7 on the calculator, and I get 5,082. And so to work out density, to work out mass even, we're going to do volume, density times volume. So density is 2.1. Let's just check the units, grams per centimeters cubed, so that works. 2.1 times 5,082. So 2.1 times 5,082, and I get 10,672.2. Now check out the unit of mass in the density. It's grams per centimeters cubed. So that's going to be grams. Now be careful, because the answer is wanted in kilograms. So I'm going to divide that by 1,000 to get it in kilograms, and it says to 2 decimal places. So it's going to be 10.2 0.67. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88, and then we have 2 shoots coming from it. Now I need to find out which 2 numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. Now whenever we get to a prime number, we always circle it, because that's finished. So 44. Get another 2 out of that, we'll divide another 2 out of that, so 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you're going to write 2 to the power of 3 times 11. Now don't work that out, because that will give you 88. So 2 cubed times 11 is 88. Okay, so this question's about exchange rates, and this part here is quite important. If I just rewrite that to make it a bit bigger, this is basically saying that to get from pounds to dollars, we just need to times by 1.42. And you can get that by just dividing the right hand side by the left hand side. Now 1.42 divided by 1 is just 1.42. So the problem with this question though is that it wants the answer in pounds, so we'll need to convert both of these things into pounds. So we're actually going the other way. When we go the other way, instead of times, we just divide. So we're dividing both sides, or we're dividing dollars by 1.42 to get to pounds. So we've got $3,000, and we want to convert it into pounds. So we're going to divide it by 1.42, and I'm just going to type that into my calculator. So 3,000 divided by 1.42, and it's to the nearest pound 2112.6, and we'll round to 8. Obviously to 2 decimal places, because money is always to 2 decimal places. So it says also that that the laptop costs £2,500 in the UK, and how much cheaper is the laptop in the USA than the UK. So what we need to do now is we need to do £2,500, which is the price of the laptop in the UK. We're going to take away the £1,112.68, And on my calculator, I'm just going to type in 2500, take away answer, and then press equals, and it gives me the answer of 387.32. So it's £387.32 cheaper. For these types of questions, always make sure that you show your working, show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102, and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees because if you look at this, I'll use a different colour, this angle here and this angle here are Z angles or alternate angles, or you can say that this 52 degrees here is equal to this here, which is also 52, because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103, and therefore that's going to be 77 degrees. So my answer is 77 degrees. Okay, so to do this question, I'm going to start off with a number line, and I'm going to put the number given to us in the question in the middle, so 89.6. Now it says it's the nearest tenth of a second, so what I want to do on the left hand side is put the next number down. So what could it have rounded to if it was slightly less? Well, the next one down would have been 89.5, and the next one up on the other side would have been 89.7. Now to find the bounds, we just find the halfway points, and this left hand one will be the lower bound, the right hand one will be the upper bound. So that's going to be 89.55 and 89.65. Now it says it wants it as an error interval and use t for the time. So we put t in the middle, then we put the greater than sign on the left hand side, and then just the normal inequality on the right hand side. Now these two signs here will always be the same. Okay, so when you're asked to do an error interval, it's that way around. So we're going to do our 89.55 on the left hand side and 89.65 on the right hand side. Now the reason why the inequality has an equals underneath it on the left hand side is it can be 89.55 and still round to 89.6. The reason it doesn't have one on the right hand side is 89.65 would have rounded to 89.7. So if you just remember, the things in the blue circles are always that way, and the letter it asks you for, just put in the middle. If it doesn't ask you for a letter, you can just pick any letter you want. You can call it X or something. And then the lower bound is on the left hand side and the upper bound is on the right hand side, and the lower bound's always here and the upper bound's always here. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got two decagons, and so that means they are 10-sided, and you can just count the sides if you want, but if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out one and then double it, and then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got two exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. Okay, so there's quite a few different ways you can do this question. I'm going to find out length CB, and then I'm going to, from that, find out length CE. So this question asks us for length CE. Now CE is the length that's shown at the bottom here. This is CE here. Okay, so that's the one we're trying to find. Now I'm going to first of all find out what CB is. Now what I'm going to do is just label this X, and I realise that it needs to be trigonometry because this is a rectangle, that's a right angle, so I'll need to use trigonometry for it. So we've got opposite and we've got the hypotenuse, so we're going to use sine, so SOH. So it's going to be sine 68 equals 27 over x, and I'm going to times both sides by x and divide both sides by sine 68. So that gives me x equals 27 over sine 68. And so if I do that on the calculator, 27 over sine 68, and that gives me 29.1204. And I just do a few more decimal places than usual because it's not an answer and you should never round your working out. If it's asking for one decimal place, I think 4 decimal places should be enough, but I'm going to try and keep it into the calculator if I can. So the next thing I need to do is work out CE. Now I'll need this angle here, which actually I can just take away 68 from 90 because it's a rectangle, the whole thing will be 90 degrees. So I'm just doing 90 take away 68, which is 22. So that's 22 degrees. Now I'm looking for this one, so CE. I'm going to call CE Y, and I've got, so what have I got? I've got the adjacent here. So this is now the adjacent, and I've got the hypotenuse because this is opposite the right angle. So this time I'm going to be using cos, so it's CAH. So cos 22 equals equals my 29.1204 blah 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 over y. So again, I'm going to times both sides by y and divide both sides by cos 22. So y equals 29.1204 blah 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 over cos 22. Now I kept that in my calculator, so I can just press divided by cos 22. Press equals, and it's 31.4074 blah blah blah. and it says it wants the answer to one decimal place, so it's going to be 31.4. Now, if I lost you a little bit because I went quite quickly through trigonometry, this is a kind of question you do when you're quite happy with trigonometry. There's loads and loads of videos on the site that go through right from the basics of trigonometry. If you want to do these questions completely within the trigonometry triangle, then that's absolutely fine. You'll get the same answer. In this question we're asked to compare two banks, and normally when I'm asked to compare something I just put a line down the middle of the working out and I put one of them on the left hand side and one of them on the right hand side, and as long as it's identifiable which one is on the left and which one's on the right, you don't need to necessarily put the whole name down, but you can do. So I'm going to start with a super bank. It says we have 2.3% for the first year and 1.8% for all other years, and we're doing this for 2 years at £300. So first of all I want to work out what the multiplier is. Since this is the calculator paper, we use the multiplier method. So we start off with 100% always, and compound interest means we're gaining money, so we're going to go up by 2.3%, so that means we'll have 102.3%. So as a multiplier, what we do is we just divide that percentage by 100 to get it as a decimal into what we call a multiplier, 1.023. So if I times 300 by that, that will tell me what we have after year 1. So let's do that on a calculator. 300 times 1.023. And you might need to press S to D. And that is £306.90. Okay, so that's year 1, and we might as well just write year 1 somewhere. Okay, so year 2, we've got that £306.90, and we need to work out the multiplier for 1.8. So I could go through the same method as before, but actually when you start using multipliers you realise how to just go straight there. So it's going to be 1.018. But you could do 100 plus 1.8 is 101.8 and then divide that by 100. And what's that going to be? So that equals came out a bit wrong. So what's that going to be? So 306 and times 1.018. And that says it's £312. And I'm going to round this to 42. I'm going to round it to the nearest penny. Okay, so that is super bank. That's how much we'd get. Now, the great bank's a bit easier because it's just going to stay at 2.2. So let's work out as a multiplier. 100% plus 2.2% equals 102.2%. And then as a multiplier, that is 1.022 by dividing it by 100. So we're going to times that £300 by 1.022. So 300 times 1.022, and I get £306.60. Then I'm going to times that again by 1.022, so times 1.022, and this time I get 313.34. Ooh, actually, that would be 5 if I round it to the nearest penny. Okay, so it says, which account will give her the most money? Well, looking at that, it's going to be the super bank. And when you're writing down an answer, make sure you write down the full name. Oh, it's not going to be the super bank, it's going to be the Great Bank. Look at that. So Great Bank Inc. And it says by how much, so I'm going to get that by how much. Let's show the examiner what I'm doing. So I'm going to do 313.35, take away 312.42. So 313.35, take away 312.42. And I get the answer of 93p. So £0.93. Now, if you hadn't have rounded both of those, you might get a slightly different answer. And actually, technically, you shouldn't have rounded them until you got the answer. But on a question like this, where you're rounding it to the actual money she would get, they wouldn't pay her half a penny, then either answer would be correct. And in this bit here, you could have done all of this just as one bit. You could have just written 300 times 1.022 times 1.022 or times 1.022 squared. That would be absolutely fine because you'll get the same answer. So this question is a simultaneous equations question, but it doesn't kind of look like the stereotypical simultaneous equation question because we're given a context for this. However, if you imagine S represents the price of the gumbo sweets and C represents the price of the raspberry chocolates, what we can do is we can write these two pieces of information as this. So 2 lots of the S plus 5 lots of the C equals, and I'm just going to leave it in pence rather than pounds. I find pence a lot easier to work with. And then we can write the second one as 4 lots of the sweets plus 3 lots of the chocolates equals 220. So to do simultaneous equations, you need one of the coefficients to be the same. Looking at the S and the C, to get the C's the same, I'd need to times the top, all the numbers at the top by 3 and all the numbers on the bottom by 5 to get them both to 15. But if I look at the S, that's 2 and that's 4, so all I need to do is times everything in this first one by 2, and it would get these S's the same. So I'm going to times 5C by 2, and I'm going to times the 180 by 2, which would be 360. So to get rid of the S here, so I'm just going to try and make this a bit clearer about where we're looking now. So we're looking, I might do a little bit further up, we're looking at this part here. Now to make things a little bit clearer, when I subtract, which I'm going to do to get rid of the 4 S's, we're going to have a bit of a problem because everything's going to be negative. So sometimes it's a good idea just to copy down the first equation again. So 4s plus, which it's technically the second equation again. Oh, let me just rub that out. There we go. So 220. So I'm just copying it again so that when I subtract, which I will do, it can just make it a bit, well, make them positive, so make it a bit easier. Now at this stage we work downwards. So we're working downwards, we're looking at these two, and these two. And with simultaneous equations you're always working downwards. Now we need to get rid of the 4s, and that's the whole point of doing this with simultaneous equations. And there's a little rule that if the coefficients are positive, so they're both the same, or both of them are negative, so they're both the same means subtract. So just remember that, same coefficient, same sign, subtract. If the signs are different, so one's positive, one's negative, if they're different, the D in different is the D in add. So if they're different, you'd add them. But these are both the same, as we can see. So we're going to subtract them. So we're going to subtract all of these three. So 4s take away 4s is nothing, which is great. We wanted to get rid of those. 10c take away 3c is 7c. And 360 take away 220 is going to be 140. So I'm going to get my lines in now, so I can solve this. And to get rid of this times 7 here, we're going to divide both sides by 7. So we've got c equals, and 14 divided by 7 is 2, so 140 divided by 7 is going to be 20. So c, the raspberry chocolate, is going to be 20 pence or 0.20 pounds. Okay, but we need to work out what the price of the gumbo sweets are going to be. So what we do is we pick one of the original equations, and I'm trying to think what's going to be easiest. I like this one. So we're going to rewrite this, but instead of c, we're going to substitute in the 20. So it's going to be 2s, which we still don't know what s is, plus 5 times 20, which is 100, equals 180. Get my lines in. Okay, so first of all we're going to get rid of that 100, so we're going to take away 100 both sides. So 2s equals 80, and then that's a times 2 there, so we've got to divide by 2 both sides. So s equals 80 divided by 2, which is 40. And so once it in pounds, that's going to be 0.40 pounds. Now you can check this by putting both of these numbers into the second equation and check that it works. So 4 times s, which would be 4 times 4, £1.60, plus 3 times c, which is going to be 60p, add the two together and you get £2.20. Okay, so in this question we're asked to enlarge shape A by scale factor -2 with the centre of enlargement 2,5. So normally we'd first of all put the centre of enlargement on, but it's already done for us. So what I need to do now is draw my ray lines, but because it's negative we know they're going to go through the centre of enlargement. So I'm going to draw my ray line. I don't need to do the bottom right one because it will essentially be the same thing. And let's do this one. Let's try and get it as perfect as we can. So it should be something like that. Okay, now the next thing to do is count how many squares we went away. So I'm going to start with the bottom left point. So we've got 1, 2, 3, 4 to get to the centre of enlargement. So if it's -2, we're going to go another 4 twice. So 1, 2, 3, 4. 1, 2, 3, 4. So we end up here. Okay. For the next one, let's do the bottom right one. So we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're just right on the edge there. Okay, let's do the last one. So this time I'm going to count the diagonals, and if you had a ruler you could just measure it out. So 1, 2, 3, 4 diagonals. So 1, 2, 3, 4, 1, 2, 3, 4. Okay, and now we need to connect them all up. So let's connect them all up. And probably it will say label it B, yeah. So label it B. And always check the width of A was 2 and the width of B is 4, so that's good. The height of it is 4, and so the height of B should be 8, which it is. And it looks unusual because for an enlargement you're used to it being the same way around, but for negative enlargement it basically just flips it. The first thing to do with this question is, instead of drawing y is greater than 2, just draw y equals 2, and you do that by just finding out where y is 2. Well, y is 2 here, y is 2 here, y is 2 here. So it's going to be a horizontal line crossing the y-axis at 2. So that's the line y equals 2. Now, the inequality says y is greater than 2, so what I want to do is shade out the region that we're not looking at. So we're going to shade out this bottom region here because we don't want that. And some teachers say shade in the region you want, but it's a lot easier to see the region you want if you shade out everything else. Otherwise you're looking for overlapping regions. Okay, so that is done, so we can cross that off. Okay, next one, we want to do the line x equals -1. Okay, so where does x equal -1? Where does there, in fact all the way up this line here. So we want to do another one. And that's the line x equals -1. Okay, so where do we not want? Well, x is going to be greater than -1, so we don't want this bit at the side here. Now, on both of the ones we've done so far, y and x can't be on that line. So instead of a straight line, we should really do a dashed line to show that it actually can't be on that line. So I'm just going to make this a dashed line. Okay, Now the last one, I'm going to do the line y equals x plus 2. Now there's multiple ways of doing this. You could do a little table and find out where the coordinates are. So you could do 1, 2 and 3, and I'm just making those up. It could be 0, 1, 2 and 3. And 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. So that's our 3 coordinates to be able to draw the line. Or you could just say, well, the gradient of x is 1, because technically that's 1x, and the y-intercept is 2. So it's going to cross the y-axis at 2, and it's going to go up 1 for every one it goes across. And notice that matches my coordinates as well. So let's draw that in. So down there we go. So it should be that line there, shouldn't it? Okay, now the complicated part of this is figuring out which side of this line to shade in. So what I do is I always pick a point. So let's pick this point here. It doesn't matter which point you pick. So at that point there, x is 4 and y is 3. So what we want is y to be greater than or equal to x plus 2. Now x plus 2 is going to be 4 plus 2, which is 6. So is 3, which is our y coordinate, greater than or equal to 6? Well, no, 3 is not greater than or equal to 6. So that shows us that we want to shade in this bit because we don't want this bit. So that coordinate was part of the region we didn't want. Now you can do the same on the other side with a coordinate, say this one here. So x plus 2 is 2 plus 2, which is 4, and y is 7. So 7 is greater than or equal to 4. Okay, last thing to do is just label it with an R. So that's the region I'm looking for there. So I label it with an R. Now there's a couple of ways of doing this question. We're asked to complete the table and then complete the histogram. You can do this by counting squares, but I'm just going to use the formula for this. And the formula, choose the right one. The formula has frequency at the top and frequency density and class width at the bottom. And it works the same way as most, or speed, distance, time and all of those ones. So we know that class width, well, let's work out the class widths for these. That's going to be 40, that's going to be 40, that's going to be 20. And I'm just looking at the distances between the 80 and the 100, so I'm doing 100 take away 80. So the next one's going to be 40, and the last one is going to be 60. Okay, now I know that I do the frequency divided by the class width to work out the frequency density. So I'm going to do 44 divided by 40. So I'm going to divide that by the class width, which gives me 1.1. Now if I go to my diagram and label that as 1.1, because frequency density is on that axis, on the y-axis, then if I look down, well, I notice that that's going to be 1.0, 0.8, 0.6, 0.4, 0.2 and 0. So it works perfectly, and then obviously 1.2 at the top. So now I know my frequency densities, I can actually work out what the next frequencies are. So the next one has a frequency density of 0.6. So I'm going to times that by 0.6, because this is our frequency densities. Times that by 0.6, so I'm going to do 40 times 0.6, which is 24. The next one has a frequency density of 1.2, looking at the graph, or looking at the histogram, so 1.2. So I do 20 times 1.2, which is 24 as well. Okay, this time I've got to work backwards. So I've given the frequency and I've given the class width. So I need to divide them across. So divide that by 40 and divide that by 60 to work out the frequency densities. So 24 divided by 40 is going to be 0.6, and 36 divided by 60 is going to be 0.6 as well. Well, that's convenient. So they're both 0.6. So the first bar is going to be at 100 to 140, and it's going to be 0.6. So 140 is going to be there. And then the next bar is going to be 140 to 200. So it's a slightly longer bar there. And I'm just putting these off center so you can see them a little bit better. Now you don't need to shade these bars in, just draw them with a pencil and a ruler, and then that's it. So this question involves composite functions, FG. And the way this works is that the letter closest to the bracket always goes first. It's like a line, people or functions lining up, and then F will go after G's gone. So G is this bit here. Okay, so 3x minus 3, and then we're going to feed that into function F, which is just times it by 5. So we're going to start off doing function G. And when we've done function G, we're going to do function F, which just multiplies it by 5. So 5 times 3x is 15x, 5 times 3 is 15. Now it says it equals 30, so we're going to get equal to 30. In fact, I should really put all of these equal to 30. And then we're going to put our lines in and solve it. Line went a bit short there. Okay, so we're going to add 15 to both sides. So that gives me 15x equals 45, and then divide both sides by 15. So we have x equals 3. So the answer to this is x equals 3. There are quite a few different approaches for this question. One thing we can do is try and find length AD by using the cosine rule. And the other approach, which I'm going to use, is I'm going to work out this angle here using the sine rule, and then work out this angle here taking away from 180 degrees. Then when I've done that, then I can use the trigonometric area formula. So I'm going to work out the angle I marked first, so that is angle ADC. That's what I want to work out first. Now to do that, I'm going to call that, let's call it x, so it's a bit easier to write. So I'm going to use the sine rule, and that says that sine x over, so this is sine x, this is x here, so it's going to be over 8 equals sine 110 over 12. And the reason it has to be that way around is obviously sine matches up opposite angles and lengths, so it's going to be those two and those two. So first thing I'm going to do is just times both sides by 8. So it's going to be sine x equals 8 sine 110 over 12. And then what I'm going to do is inverse sine both sides. Scroll down a bit more. So x is going to be the inverse sine of 8 sine 110 over 12. So let's get my calculator. So inverse sine, fraction button, 8 sine 110, close the brackets, over 12, and then come out of the fraction, close the brackets. So that tells me that x is 38.789 blah blah blah. Now I want to keep the accuracy if I can, so I'm going to keep that in my calculator. And then what I'm going to do is add that to the 110 to work out what this angle here is. And I'm going to call that y, so what is this? ACD. So I'm going to tell the examiner that ACD I'm going to call as y, just to make it a bit easier. So y equals 180 take away 38.789 blah 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 plus 110. So I'm going to add 110 to that. Then I'm going to type in 180, take away the answer. So that tells me that y is 31.2104 blah blah blah. Okay, so I've worked out what y is, which is good, because when you have a length, then an angle, then a length all together, then you can use the trigonometric area formula. And the formula is dead easy. It just says that area equals half AB sine big C. So we know the problem is actually we've got two triangles. We've got a triangle here, and then we've got an identical triangle here, and it is identical because the diagonal of a parallelogram cuts it in half exactly. So what we also need to do is then times this by 2. Now if we notice that the half and the times 2 will cancel, so it's just going to equal AB sine C. Now I've kept that number in my calculator, so I can use it with A and B. A and B are going to be 8 and 12. So it's going to be 8 times 12 times sine 31.2104 blah blah blah. So let's quickly use the calculator before it switches off. So I'm going to press sine answer, close bracket, times 12 times 8. And it says the answer is 49.7455 blah blah blah. Let's have a look and see the accuracy that I need. 1 decimal place. So let's have a look. That's going to be 49.7. Now if you didn't keep the numbers in your calculator and you rounded them, make sure you round them to 4 or 5 decimal places. So I would probably round it at least to 3 decimal places, but you normally want to go a little bit further. You might find that if you rounded it, you might get a slightly different answer to mine. Now that's why you must show you're working out, because if you got say 50 rounded to the nearest decimal place, or 49.8 or something, then if you can show you're working out, if you can show that you've done all of the steps and the reason why you got slightly off was because you rounded some of your working out, you might get full marks, but you would get at least all but 1 mark for the question. Okay, so this looks like it's a kind of quadratic question, but it looks a bit of a mess. There's a really easy first step to sort this all out, and that's to times everything by y squared. So just times literally everything in the equation by y squared. So 5 over y squared times y squared just leaves 5. And here we've got 7, and in fact I'm going to write this as a fraction still so we can see it a little bit clearer. So we've times that by y squared, but we've not really dealt with it yet. And we've got minus 3y squared equals 0. Now the y at the bottom and one of the y's at the top cancel, so we end up with 5 plus 7y minus 3y squared. And since we'll use the quadratic formula on this, it's probably easier I put it in order. So that would be minus 3y squared plus 7y plus 5 equals 0. So we've got to find out what a, b and c are. A is the number before the y squared, which is minus 3. B is the number before the y, which is 7. And c is the number on its own at the end. Then we're going to use the quadratic formula, okay, which is x equals minus b plus minus square root of b squared minus 4ac over 2a. Okay, so I'm just going to type that all into my calculator. It's a lot easier doing this than going through. I'm going to do plus first, And then I'm going to go back and change that. So minus brackets 4 times minus 3 times 5, close brackets, over 2 times minus 3. Press the equals, and I've got an answer of minus 0.57338, blah blah blah. To 2 decimal places, that's minus 0.57. I'm going to go back on my calculator and change that plus to a minus. And it also equals 2.9067, blah blah blah. So that's going to be 2.91 to 2 decimal places. And so the trick with this is just convert it into something y squared plus something y plus something equals 0. Now the major rule with algebraic fractions, or fractions generally, is that the denominators must be the same, obviously at the bottom, that's where denominators are. They must be the same when you add or subtract. So we've got to make both of the denominators the same. So what I can simply do is times the left hand side by the right hand side's denominator and the right hand side by the left hand side's denominator. Basically I'm going to times both top and bottom of this side by x, and then both top and bottom of the other side by 10 plus x. So 11 times x over this 10 plus x by x as well. Now I've kept that fraction the same because I've times top and bottom by the same thing, so it's the same fraction. That's important that you don't change the fraction. Then I'm going to times the 5 by the 10 plus x, and I'm going to times the x by the 10 plus x. Now, something I've done instinctively, and a lot of people make mistakes on, is I put brackets around the expression 10 plus x, and if you don't do that, you will end up, say here, just timesing the x by the 10 and not timesing the x by the x on the right hand side. So always put expressions that are in fractions in brackets. Okay, so now the bottoms are the same, we can just simply add the tops, and I'm going to expand that top bit. So 5 times 10, which is 50, 5 times x, which is 5x. I'm going to expand the bottom, but you don't need to. So the bottom will stay as x brackets 10 plus x. The bottom, in fact, let's do that step first to make it really clear. Okay. So, and I'll put an equals there. Okay, now we've got 11x plus 5x, which is 16x plus 50, over, and I'll expand the bottom one, so it's 10x plus x squared. So my answer is 16x plus 50, and you normally do by powers of x, so I'm going to do x squared plus 10x. Now, unless it explicitly tells you otherwise, you don't need to expand brackets, so you could leave the bottom one in brackets, but I needed to expand the top one because I was adding the 11x on. So if it's literally like that, I wouldn't have needed to expand it. I could have just left it in brackets, but read the question because it might ask you to. Okay, so this is a question on iteration, and we're given the iterative formula for a situation. Now, iteration is all about trying to find an answer, and it's a method in maths that bounces above and below constantly the correct answer, and it just gets more and more closer and closer, but it doesn't quite ever get there. It will just get more and more accurate the more times you do it. So we're looking for when to stop, and that's given here, just to 2 decimal places. So the formula is given here, and this is the only bit we need here, as well as this bit, the starting number. And in my calculator, I'm going to type in 5 minus, well, actually, no, I'm not. I'm going to press 2 and then equals. And the reason for that is it tells my calculator to use 2 if I use the answer button. Next thing I'm going to do is type in 5 minus square root answer. Now, when I press equals, the calculator will remember that the 2 is the answer and use a 2 here. Now, you might think that's a lot of effort just when I could have pressed a 2, but you'll see what the benefits are after this first run. So when I press equals, that gives me my first number, and if it comes up as a surd or something on your calculator, just press S to D. So that gives me 3.585 blah blah blah. Now, the beauty of these modern calculators, is if I press equals again, it will use the 3.585 number and put it back into the equation. So all I need to do now is just press equals, and it gives me 3.1063 blah 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 blah. Again, equals 3.2375 blah blah blah, equals 3.2006 blah blah blah, equals 3.2109 blah blah blah, equals 3.2080 blah blah blah, equals 3.2088 blah blah blah. Now, you stop when you get the first repeat of the accuracy that you're looking for. So if you look, this is the first time I've got the same answer twice, 3.208 blah blah blah. So it says it wants the solution correct to 2 decimal places. Now 3.20 is not going to be the right answer, because if I have a look, the next one is an 8. So my answer will be 3.21. Okay, so this doesn't seem like the easiest questions, because there's 3 shapes going on. There's no numbers in it at all, and we're asked to find a formula. So the first place I'd start is working out, well, first of all, what are the formulas we'll need? Well, let's have a look. So we've got a hemisphere. And some of these formulas you will be given. So a hemisphere is a volume of a sphere and then halved. So instead of 4 over 3, I can just say 2 over 3, which is half of 4 over 3, pi r cubed. The cone that we've got is going to be 1/3 pi r squared h. And then the cylinder we have is the area of the circle times the height. Okay, now we need to find out what the bits are. So for the hemisphere we just need r. Well, that's quite simple, because r is just going to be x. It's the radius of the hemisphere. Okay, now what's more difficult is to work out the height of the cone. Well, if the radius across to the right is x, the radius of the circle up is also going to be x. So we know the height of the cone is going to be 4x, because one of those x's is used on the hemisphere. We know the radius of the cone is going to be x, because it's stated at the top. So let's keep going. The radius of the cylinder is going to be 10x, and the height is just labelled as h. So that's nice and simple. Okay, now let's have a look at what this question's saying. It's saying that this thing here is going to be melted down and is going to be used to create this. So that's just saying that the volumes are going to be the same. So if I add the volume of the hemisphere to the volume of the cone, it should equal the volume of the cylinder. Okay, so we know that hemisphere plus the cone volume, and I should write volume here, show the examiner that I'm working with volumes, equals the volume of, I don't know why I wrote an S, my goodness, C for cylinder. Wow. Tell my maths teacher. Right, cylinder, there we go. So hemisphere is 2/3 pi, and we said that x was the radius, so x cubed. Brilliant. So plus the cone. Now, what did we say the height of the cone was? We said the height of the cone was 4x. So it's going to be 1/3 pi x squared, because the radius is x, and is it 4x? Let's double check that. Always double check. Yeah, it is. Okay. So the cylinder, and I'm going to leave that up so I can see it, is pi, and what's the r? So pi times 10x squared, and all of that squared, because all of that is r, times the height, so times h. Okay, so this is the formula we've got to work with. I'll put my lines down. Okay, so what we got? Let's sort out the timeses first, and let's tidy this up. So that hasn't got any timeses in it. This we're timesing it by 4, so it's going to be 4/3 pi, and I'm timesing it by x, so that's going to be x cubed. This one, I'm doing the 10x squared, so I need to square the 10 and the x, so it's going to be 100. And let's do the pi next. Pi, and it's going to be x squared h. Okay. Now, if you notice on the left-hand side, these two here are the same. They're both pi x cubed. So we can just add them together. So it's going to be 2/3 plus 4/3. So that's going to be 6/3, or just 2. So it's going to be 2 pi x cubed equals 100 pi x squared h. Brilliant. Okay. Now let's just check to see what it wants. It wants a formula of h in terms of x. So it wants h equals. Okay. So first thing I need to do, well, let's have a look. What's easy to do? Well, what's easy to do is just divide both sides by pi. Let's get rid of the pi's. So 2x cubed equals 100 x squared h. Now we want h on its own, so we're getting close. We need to divide by the x squared first to get h on its own. So I'm going to divide by x squared. So we get 2x equals 100h. So we can already see we're really close. So to get h on its own, we need to divide both sides by 100. And that's going to be 2x over 100 equals h, or h equals, and we can cancel the 2 and the 100. We can divide them both by 2. Equals x over 50. So our answer is h equals x over 50. Okay, with these questions, you're always going to have to find one and then another. The first one we need to find to work out BH, we need to work out what the length of FH is. And then when we've got that one, then we can find out the length BH. So I'm going to call the length FH x, I'm going to call the length BH y, and I'm just going to draw out the two right angle triangles that we need for this question. So I'm going to start off drawing out FEH, I mean. Okay. And this is x, this is 2 centimeters, that's obviously FEH. And this is going to be 3 centimeters because it's going to be the same as on the other side. So that one is the same as this one. So that's also 3 centimeters there. Okay, next triangle I'm going to draw out is the other one that we need. That's B at the top there, isn't it? Yeah. So BFH. And we called this one Y. This one is X. and the next one is the height there, which is 4 centimeters. So that's also going to be 4 centimeters there. So that's 4 centimeters. Okay. Now, to work out what x is, we use Pythagoras Theorem. Loads of stuff on the site to help you with that if you don't know. So we'll end up with this. 3 squared is 9 plus 4. This could be 13, so it's going to be root 13. So we know this one now here is root 13. And so to work out what y is, we also use Pythagoras Theorem. So it's going to be 4 squared plus root 13 squared. 4 squared is 16 plus root 13 squared just gets rid of the root, so that's just going to be 13. So that's going to be 29. And on the calculator, root 29 is, so y equals 5.385 blah blah blah. So it's 2 decimal places, that's 5.39. Now there's an interesting thing with this is to work out what y is, you could also just do the square root of this squared plus this squared plus this squared, and if you try it out you'll get the same answer. First thing I do with this question is just write the numbers out. They're a bit small in the question. Now with all sequences we're interested in what it goes up in. So we're interested in what these go up in. So if you've got a calculator you can just do 25 take away 13. If it's on an uncalculated paper then you can just quickly do it in your head. And I'm going to do this for a few of them. Now you might notice straight away that the next one goes up in 18. Well, let's have a look at the next one. That goes up in 24. And the last one goes up in 30, which is what we'd expect. So they're not going up by the same amount. Now when they don't go up by the same amount, we need to have a look at the second difference. If they don't go up by the same amount in the first difference, that means it's not going to be an arithmetic sequence. We're not going to use the standard linear nth term, the one that you're probably used to. For a second difference, it's going to be a quadratic. Let's check to see if there's a second difference. So that's add 6, this is add 6, and this is add 6. So we know it's a quadratic sequence, so it's going to involve an n squared somewhere. Right, the step that people have difficulty with is you get the second difference and you halve it. And that's all you've got to do. Now, that halving, the dividing by 2, won't ever change. You'll always halve it. And you get the number 3. This 3 is going to be the coefficient of the n squared. So I can fill that into my answer now. Now the problem is we don't know what else we need. What we need to do is write out the sequence 3n squared. So let's number the terms. So we've got the first term, second term, third term, fourth term, and fifth term. And so we've got our sequence, which is, I'm just going to copy this out again, 13, alright, 35, it's 25, 43, 67, and 97. And we're going to write out the 3n squared, which we've just discovered. Now, that means we just square the sequence number and then times by 3. So 1 squared is 1, times 3 is 3. 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, and times that by 3 is going to be 48. 5 squared is 25, times 3 is 75. Now what I want to do next is I want to subtract them. I want to subtract the sequence I want to do the sequence take away the 3n squared. We know that 3n squared is a part of it. We need to just take it away so we know what's left. So 13 take away 3 is 10. 25 take away 12 is going to be 13. 43 take away 27 is going to be 16. 67 take away 46 is going to be 19. And 97 take away 75 is going to be 22. Okay, now we end up with a little sequence here. Okay, we've got 10, 13, 26, 10, 13, 16, 19, 22. Now we find the difference in that. So that's a plus 3, plus 3, plus 3, plus 3. Now that's a linear sequence. Now we've got to find the nth term of it. So to do that, we find the 0th term. So we go back 1, we subtract 3. And that tells me, so I'll say linear. So that's going to be a 7. So we know we're going to add 7. And we know it goes up in 3, so it's going to be 3n plus 7. So we got our 3n squared already, and we just need to add 3n plus 7. So the first thing you need to do is find out what the quadratic sequence is, the quadratic bit of it, the squared bit. Then you've got to find out what the linear bit of it is, and then just add them together. I hope you enjoyed that video. If you liked this video, please click like. If you really liked it and want to support this channel, then please click the subscribe button. I can never say that properly. Thank you very much.